Once again, good evening to all of you. Here, our today's speaker, Dr. R.K. Chaurasia sir, has joined. Let me share my screen here. We are in module number 3, that is signal and image processing. We had a speaker like Dr. Kumar sir. Today, we are going to have a lecture with our eminent speaker, Dr. Rahul Kumar Chaurasia sir. He has done his PhD from MIT Raipur, and he has published many international and national journals papers. His research area is machine learning, pattern recognition, and other biomedical signal processing like that. Here today we will going to have a lecture with him on artificial intelligence, machine learning with MATLAB. Here I'm inviting Dr. Rahul Kumar Chaurasia sir for today's session. Welcome, sir.
Am I audible, sir?
Yes, sir, you are audible, sir.
Okay, actually there was some connection problem, so I was not able to hear you and as well as not able to speak.
Okay, sir. Let me clear it.
So can we start now, sir?
Sure, sir, we can start.
Okay. Good morning, good evening to all the participants. I do not know much about the participants, like their background and all. So it was told to me that they all of you are the BTech students from computer science, electronics, and electrical background. Is it correct? Anyone from the students? Anyone would respond? So in which year you are studying or all those things?
Sir, myself Kapil Gupta. I am pursuing PhD from IIIT Jabalpur in signal and image processing.
Under guidance of whom?
Dr. Barun Bajaj, sir.
Okay. And somebody else?
Myself UP Verma. I am doing PhD in in Earth and Atmospheric Science. I have some need of programming and computer knowledge. That's why I am doing this. I have some data interpretation and data modeling. That's why I am requiring it. Thank you, sir.
Okay, one more thing. I asked Mr. Shashi Gopal Panda to share with you one assignment. That is not kind of assignment. That is something we will be trying to do in this lectures, and some 2D data was shared. Have you got it?
That is in Google Classroom, sir. Actually, we have shared that in Google Classroom. They can download that.
Okay. So actually, I have this 2-hour lecture. I am trying to divide it into 2 parts. The first part is I will be giving an introduction to machine learning. So I think if you all are PhD people and all, maybe you will already knowing these things. Normally, I also introduce some of the machine learning methods which I apply during this particular session. So here I'm not going to do that. I will just tell you 2 machine learning methods and not going to give the description of them. There are famous methods called support vector machine classifier and nearest neighbor classifier. If it is required, we can discuss it, or I can give you the slides of them. So I will be just directly using them as a MATLAB tool. And okay, so let me start presenting. I have to see where it is. Audio turn, camera off, turn on mic, present now. Okay, my entire screen. So my screen is visible now?
Yes, sir, it's visible.
Okay, so my name is Rahul Kumar Chaurasia. I completed my BTech from MANIT Bhopal, and then I did my MTech from IISc Bangalore, and then I joined as assistant professor in NIT Raipur. So there I worked for 6 years, and I also completed my PhD there in the area of brain-computer interfacing that involves signal processing, EEG signal processing, machine learning, pattern recognition, etc. Then later I joined NIT Jaipur also for around 2 years. I worked in MNIT Jaipur. And then after, because Bhopal is my hometown, I joined back in Bhopal. So I'm going to turn off my camera because we are now going to concentrate on the slides. So my first slide is introduction to AI and ML. So that will be, I will be trying to cover in the first 1 hour. And then later on, I will be showing you a small code in this MATLAB, and just let me give you one small kind of demo of what we will be doing. For example, this is some data that we will be trying to do, and I will try to ensure that every one of you are able to plot the data, as well as, for example, I just give you one more example.
Sir, we need to increase the font size.
Okay, that I will do. Okay, when I will be showing, I will be increasing the font size as well, and will trying to show you how I can apply some machine learning on this. So, definition of AI. Anyone, what is AI and where have you heard this name? I want people to speak from the other side also. Otherwise, I'm not knowing whether somebody is listening to me or not. There I can see 17 participants are there. So anyone, what is AI and what does this mean? Nobody knows what is AI. It is everywhere in your mobile.
Artificial intelligence.
So what is artificial intelligence? Because if I know how much you know, then I will be able to give some of the informations. Okay, so artificial intelligence, that is intelligence which is given artificially to machines or to computers. It is used to describe machines that mimic, that is tried to copy the cognitive functions of human mind, such as learning and problem solving. So our mind learn things and also can be used for problem solving. So artificial intelligence is a thing, or is a kind of a methods which we give to computers to learn things. The traditional problems or goal of AI research includes reasoning, planning, learning, natural language processing, perception, and ability to move objects. So these all kind of tasks are done by robots and by computers and by mobiles, and they use artificial intelligence in them. Artificial intelligence is a big term. We use a term, artificial intelligence, computers with the ability to reason as human. But in artificial intelligence, there can be lots of logics and for loops and all. Some of the things are also not mathematically defined. So mostly the engineers, especially computer science, electronics, electrical engineers, work in the area of machine learning. Machine learning gives the computer the ability to learn without being explicitly programmed. So you just provide a lot of data set, and the machine learns from the data set. And a subset of it is called deep learning. Nowadays, it is very famous. So basically in machine learning, there are several methods. One of the methods is called artificial neural network. So in our brain, we have neural networks. उस न्यूरल नेटवर्क के बेसिस पे एक नेटवर्क बनाया गया जिसको नाम दिया गया आर्टिफिशियल न्यूरल नेटवर्क ANN, और उसको फिर बाद में एक कन्वोल्यूशनल न्यूरल नेटवर्क वर्ड यूज किया. अगर आपने डिजिटल इमेज प्रोसेसिंग सब्जेक्ट पढ़ा हो तो उसमें बहुत सारे फिल्टर्स यूज करते हैं. उसी तरह के फिल्टर अगर हम इमेज पे यूज करें तो उससे कुछ डेटा इन्फॉर्मेशन निकाल लेते हैं और अलग अलग डेप्थ में जाते जाते. So that is called deep learning. So we will be focusing some of the machine learning methods in this lecture. So the machine learning is a type of artificial intelligence. So it is a subset of artificial intelligence that gives machines the ability to learn new things from the training data without being explicitly programmed. मतलब हमको उस डेटा के लिए मशीन को कैसे लर्न करना है वो उसको नहीं सिखाना है, वो खुद सीखेगी. we will be doing this thing on a data set that I have provided to you, and you will be able to see that machine learns itself from the data. These types of programs can teach themselves and grow when they are given new data to work with. Okay, so this is important. So what are the examples of machine learning?
Hello.
Yes.
Sir, one request to you. Since people are from across India as well as from outside India also, so we can have a conversation in English only.
Only in English? Okay, no problem.
Yes.
Okay.
Okay, sir.
So
Thank
some
you.
of the examples of applications of machine learning are like optical character recognition. So I think all of you have gone through these examples like handwritten text recognition, sorting letters by postal code, input devices for persons with disabilities, or printing text recognition. So biometric applications, if you are working in a company or maybe if you are a PhD scholar, then they have the system called fingerprint recognition system. Even your mobile have face recognition system, and speech recognition are some of the examples of biometric. These are all established and well-known applications which are already being implemented and are very successful there. Diagnosis systems like medical diagnosis, X-ray. There are several medical signals like ECG, which is called electrocardiograms, which are taken from heart, EEG, which are called electroencephalograms, which are taken from our brain, and ECG is taken from heart, and machine diagnosis. So these are some of the diagnosis applications. Military applications include automatic target recognition. There are a lot of examples of machine learning. The future examples of machine learning and pattern recognition, PR is called pattern recognition, accurate detection of stages of diseases from medical signals. For example, if you will see in the COVID time, a lot of people claimed that their deep neural network can find whether you are having the COVID disease or not based on the data set provided. A lot of people are working on prediction of heart attacks. So maybe in next 1 year, what are the chances that you will get a cardiac arrest or heart attack? So based on that, they can do this. This image shows, this is the image of the retina, and there is a disease called diabetic retinopathy. So with more than 99% accuracy using the retina image, they are able to know whether you are having the diabetic retinopathy or not, and not even whether you are having it or not. It's kind of plus and minus. If it is there in your eyes, they are having the stages mild, severe, very severe, and moderate. So the accuracy of detecting the stage of disease is also very high using the machine learning. So these are some of the feature applications which you will see. Using your mobile, you will be able to detect your sugar level and all those things. So basically all kind of sensors can be used. So more applications include understanding human speech and language translation. You can see in Google there is an option to search in Alexa device, Echo Dot device. You can speak and it recognizes your speech. Language translation options is available. Like in Facebook, you can write in English and then it recognizes in Hindi. Strategic gaming systems. Driverless automatic cars are also example of machine learning. And natural language processing, that means processing the paragraph that you have written, so whether it is grammatically correct or not, or whether it is correct according to the English literature or not, or any other language. Neuromarketing, so this is very, very new application through brain-computer interfacing. BCI means brain-computer interfacing, neuromarketing. So nowadays, for example, say Amazon, they have millions of products in their website, but on their screen, they can display only few of them. So they are using nowadays neuromarketing. Basically, they are sensing your responses, your brain responses. And if you are happy in seeing something, they will show you more of that. And if you are not happy in seeing something, that will not show to your screen. So that is kind of neuromarketing. And routes finding through Google Map. We find the routes through Google Map. It tells you how much time will it take, how much traffic will be there. So all these are the applications of machine learning. Inspection of fruit and vegetable quality online, chatbots, and many more. If you see in India, there is a company called Zomato. They removed lots of their customer care executives because they have an automated chatbots. They know there are around maybe 100 questions which are everyone asking again and again. So they have automated chatbot for them. You ask the question, they give the responses, and the machine is learning from your responses and all, and AI-based robots. So is there any question which somebody wants to ask at this stage?
Yes, sir.
Yes.
The what is the information regarding the neuro related something about the
Neuromarketing means, sir, there is a device, I will show you. There is a device which is called EEG cap or maybe EEG headset kind of thing. So instead of wearing it in our ears, we wear a device, electrode sensors on your brain. So whenever some brain activity occurs in your brain, so because of lots of neurons and all, a very small potential that is in millivolt or maybe in microvolt range is generated on your scalp, that means on your head. So through those electrode sensors, we can record your EEG signals. EEG signals are called electroencephalograms, which are recorded as a brain activities. So whenever there is some change in your brain or some kind of activity, maybe it is called a cognitive task. So that is signals you can record. My PhD is on the signals of EEG, and I am also mostly working in EEG. So through these responses, you can have lots of applications, whether a person is having calm stage or sleep detection, whether is he having proper sleep or not, or if he is recognizing something or cognitive task he is doing, whether he is doing it or not. If you want to move the cursor using only your brain, you can do it. If you are using a wheelchair, you can use it. Or if you are having a smart home and you want to control lot of things like your TV and other devices, appliances through the EEG signals. So all those also you can control. So the application now is being extended. All these are the work which are already being done. The application of the EEG is being extended for neuromarketing. Mostly the companies which are online product selling companies like Amazon is the biggest one of them. They are using or they are doing research on this. So this is a new research area. Neuromarketing.
One thing,
Okay,
sir.
sir.
One thing. Can the program be set up for detection of the loss of memory or some detection of tumor in the brains or some neurotic disease, etc., by this machine learning?
Yes, sir. This is very well developed field of research for tumor detection. They need the fMRI images or maybe the CT scans or some kind of X-rays and all. And people are working on tumor detection. And if you will search for the research papers or the outcomes, so you can find a lot of work which is being done on this. Also, I will say there is a website called Kaggle. In that they have lots of competition launches and they provide you data set. There are other websites for biomedical signals as well. Most of the universities also provide. So the way to do research on this is like you find some research papers in maybe IEEE transactions or maybe in Scopus or Google Scholar, then you download those papers and you see they have used some kind of data set, and they also will give you the link of the data set, and you will find the corresponding data set which you want. For example, for brain computer interfacing, there is a lot of data set which is called BCI 2000.
Thanks.
So what is the pattern recognition or learning in human? So why the word machine learning? Before that, we will understand the concept of human learning. The basic attribute of people is to categorize the sensory input. So our brain can sense, or our body can sense a lot of things. We have the eyes to sense the videos and images. We have the ear to sense the audio signals. We have our tongue to taste the things. We have our nose to smell the things. We have our body to feel the temperature, to feel the texture. So all these are the patterns, I call it in terms of our computer language, and pattern recognition system is our brain, which kind of keeps on assigning the class level and keeps on learning. So one example is your brain is seeing examples of pattern recognition tasks when reading facial expressions. So if you see a new baby is born, he has not seen any face before, but after maybe 20 days or maybe of 6 months of age, he is able to recognize the facial expression. Whether you are smiling on him, he will also smile. If you are being angry, he will give some similar kind of response. So he is able to recognize the facial expression. So because he has learned through those different faces which he has seen, and his mind is keep on assigning the class levels kind of thing. Then recognizing speech. Maybe a 2-year-old kid will be able to recognize what you are saying. He will be able to understand your words and sentences and recognize your speech, or maybe who is speaking, whether he is the father or mother or something like that. Then reading a document. So if you want to read a document, maybe if a 5-year-old kid want to read a document, he has to go through a learning process. Learning means first learn the alphabets, then maybe the words, then sentences. So this requires some kind of training. And there is one more important thing through this I will like to tell. The machine will be able to recognize only those things for which it has been trained. Okay, I will repeat again. Machine will be able to recognize only those things for which it has been trained or for which it has gone through the learning process. For example, we all are adult people, but we cannot, most of us cannot understand or recognize the Chinese text. We know well in English and other languages, our regional languages, but we have never been trained on Chinese text or Japanese text, so we cannot read those documents. So same happens with machine. If you will train your machine learning method for, say, tumor detection, and then you use it for audio classification, it will give very, very poor accuracy, or maybe it will not recognize at all. So if you are training your machine to read the documents for your adult person or some other person, then the machine will be doing that task very well and no other task. Then identifying a person by fingerprint, tougher than reading. This is tougher than reading because most of us have not gone through those kind of trainings, reading a document and all those things. So, but if a person has been trained for that, he can do. But nowadays, this task is not mostly done manually because machines can do it very well. Diagnosis from medical images. So if you see, you just take an X-ray of your maybe of your hand, and maybe there was some kind of fracture, you will not be able to see it, or maybe not will be able to understand it. But an orthopedic doctor will be able to do it, to recognize whether you are having some kind of fracture, because he has gone through the training of those, or he has done the learning, and every time he sees it, his learning increase. Wine testing is one of the more better example. So the good companies who sell very costly wines, they because they are using grapes and other raw materials, so the raw materials quality can change, and the wine making process is there. So they want that every time and every slot of the wine should taste according to their like brand and all. So they have the people who taste the wines and tells whether it is a good taste or whether it is the taste which you are already selling. So this is one of the examples which says human being can learn different things if the past data set is provided or a relevant data set is provided. So now I will move to the next slide. By the word machine learning, we can also do same kind of teaching or same kind of learning machine can do for recognizing the patterns or for assigning the class levels. But now the limitations comes. Machines means computers, and computers only understand the language of numbers. Okay. So language of numbers means whatever input you can convert in terms of numbers, you can use them as patterns. So now if you see, there is no method which can sense the taste, which can sense the smell till now. Maybe people are working on sensors for taste and smells, but a lot of things we can sense, like we can sense the videos, we can sense the images in terms of a digital image, which is a combination of pixels, and pixels has the intensity values. We can sense the audios, where the audios are just a one-dimensional signal with different amplitudes. We can sense temperature, sensors are there. We can sense pressure, we can sense humidity, we can sense a lot of things. And we ultimately want the class level. But computer does not have any brain. So what we do, we have a feature extractor. Feature means the information which can be useful for classification. We call it as feature. And then that information is given to classifier, like our brain. But the classifier first has to be trained, or it has to go through the learning process. And for whatever kind of pattern it has been trained, it will be able to later classify for the same kind of features. Okay, so I will just give you one example of this. Is this notepad visible to all?
Yes, sir.
Yes, sir, it's visible.
Suppose you are having a lot of images of cats and dogs, and you want to design a classifier which can distinguish between cats and dogs using a machine learning method. So I have got images I1, the image 1, and I2 and I3, like that. I have got, say, 100 images, or 1000 images, I1000. I means image. Then this is the image which I call it as a pattern. So I have 1000 such patterns. I also know the class of them individually. So I know, say I know this one is for cat, this one is for cat. So like this, maybe like 450 images are of cat, and the remaining 550 images are of dog. Somehow just assume that you are able to do some kind of processing on this image, like segmentation and pre-processing. So you are segmenting out the image of the animal, and you have taken the images of the animals standing at the same position through the same camera. So maybe you are able to measure the features like length of the animal, and maybe the length means uske starting se end tak kitni length hai, and height of the animal. Okay, so for first image I1, I will extract the feature x1, which consists of x11, x12. X11 is nothing but the length of animal 1, which can be cat or dog, and x12 is the height of animal 1. So this is called feature vector of image 1, and feature vector I call it as x1, which is belonging to R2, which is a two-dimensional feature vector. I can also have three-dimensional. If I measure some other things like the color of the animal, then it will be the third feature. Generally in machine learning, we measure like 50, 60 features like that. Okay, then I2, the second image, I will measure the x2 feature, x12, x22. X12 is the length of the second animal and height of the second animal. So I have x2. I also have y1, y2, which is the class. So y1, for example, I'm calling cat as +1, and maybe this is dog, which is I am calling as -1. So y2 is -1, y1 is +1. So I will say mathematically, I have a data set which is I1 to I1000. Then for this data set, I have the feature vectors. So which for corresponding to each image, I have x1, x2 till x1000. So I have 1000 feature vectors. Corresponding to x1, I have y1. Corresponding to x2, I have y2. And corresponding to x1000, I have 1000. So I have 1000 feature vectors, where each xi belongs to R2. It is a two-dimensional feature vector for all I. And each yi is either +1, so I will say it belongs to +1 or -1. Yi +1 means it is a cat, and yi -1 means it is a dog. Okay, so feature extractor makes some measurements on the input patterns. X is called feature vector if X is belonging to n-dimensional values. Classifier map each feature vector into class level, and feature to be user problem specific. जैसे cat और dog में I am measuring like the length and the height, because I somehow think that the length and the height are a good feature for measuring the difference between cat and dog. Maybe you can use the color, or maybe you can use the number of other kind of textures and all those things. So what I can do, I have a plane where this is feature x1 and this is feature small x1 and small x2. X1 is the length and x2 is the, so maybe on some scale this length is there, maybe 1 meter or centimeter or inch, you can do whatever, these are the values. So this is one scale. I am going to plot it. So I will also be showing you similar kind of plots in MATLAB. So maybe all the cats, so there is one cat whose length and weight height was 2. There is one more cat like here. So all these, the red circles are basically different cats feature vectors. It's a two-dimensional data. I can plot it like this. And maybe all the dogs, maybe because generally the dog's lengths and heights are more than the cat generally, but not, it is not true for all of them. So these are all the dogs. So I will have 1000. So this is all belonging to dog category, and this is all belonging to cat category. So we will having 1000 such vectors. We will call it as training data. All the data, 1000 training data points. I will call 1000 training data points. Now I will teach my classifier to learn from this data. Okay, so that is the word machine learning. In machine learning, the algorithm can learn itself without being explicitly programmed. I will not program according to this. I will just give this data set I will also not give the plot. I will just give the data set, this data set, xi and yi, 1000 data points. And you will see magically, not magically, using some mathematical tools, an algorithm may be learning something like this. Okay, so maybe I call this as an SVM classifier. There is a method called support vector machine. So this is an SVM classifier, which it itself will learn. So somehow like it is trying to have more number of red points below this line and more number of blue points above this line. So it has some kind of optimization algorithms running behind it and trying to classify the data on the different classes. Okay, so that I'm not going to cover this, but there are several other algorithms like neural networks. So there is SVM, there is artificial neural network, there is k-nearest neighbor classifier, there is called linear discriminant analysis, there is called Bayes classifier, there is called hidden Markov models. Some are good for sequential data, some are good for normal data. So a lot of things are there. So machine learning method, what it does, it without being explicitly programmed, it learns how I can classify the data into different sets. So this is the learning is completed now. Okay, now next time you will give the new data set or call the novel data set or test data set and ask the machine to classify it. So this SVM, support vector machine, what it will do, it will be simply seeing whether the data is below this line or above this line. If it is above this line, it will classify it into dog category, and if it is below this line, it will call it as a cat category. So important thing is here is you should use features which are discriminative. Discriminative means if you want to discriminate between cat and dog, you should use such kind of features which are discriminative between cat and dog. If you use like number of legs of the animal as a feature, it is not a discriminative feature at all. Number of eyes of the animal, whether his ear size is small or less. So some features might not be very distinguishing. Okay. So if you are using a good set of discriminating features and you are having a sufficiently large training data set, there is no such things like this is sufficient enough. More number of data points means more learning. It is like our brain. If you are trained with more number of examples, your brain will be able to distinguish with a better accuracy. The same kind of things happens in machines. Classifier maps each feature vector into class level. So first it learns. Next time onwards, when you give the new pattern, for those patterns also it will calculate the same feature and will assign the class level, like class cat and dog. And feature to be used are problem specific. If you are doing this thing, for example, audio signal processing, then you have to take some other kind of features like capstral coefficient and all. If you are using this same classification to distinguish between two students, so whether you want to select the student in your company or not, so maybe the students are my patterns, then the features to be used are maybe like his CGPA, his marks in the interview, number of coding language he knows. So those are the features, and which are actually distinguishing features between a good student and a bad student. So any doubt
Sir,
at this point? Yes?
So there's a question in chat box that can you detail again about SM, AMN, etc.
Okay. So there is a classification method called SVM, support vector machine. So maybe you want me to go into that. So actually, there are a lot of classification methods. I will just give you one example of simple method called KNN classifier. Okay, k-nearest neighbor classifier. Then also I will give an example of support vector machine class. So KNN is called proximity based learning. See this example. If a new device is in the market, which is like this laptop, and you have those older devices, these are the training data set, and this is the new test data set, and you want to categorize into one of the three classes, whether it is a pager or phone or laptop. So anybody says which class it should belong to, it should be like a desktop, because most of its features are matching with desktop. So they say if it's box like a duck, quacks like a duck, and looks like a duck, then it probably is a duck. That means if most of the features are similar, then it should fall to the same category of class. So how the KNN classifier works? How the KNN classifier works? These are the feature vector corresponding to cats. And these are the feature vector corresponding to dogs. Dogs. So the KNN classifier, KNN I'm going to explain here, it does not draw any line. It does not do any kind of that thing. You have a new animal, you take its features X and call it as X1, X2, and try to map it here. Maybe it is mapped on this place. And in K is a number, so you call K, say 5, so 5 NN, 5 nearest neighbor. 5 nearest neighbor. So based on who are your 5 nearest neighbor, your class will be decided. For example, this is the first nearest neighbor, this is the second one, this is the third one, maybe this is the fourth one. Based on the distance, you can see Euclidean distance, 5. So in 5, you can see 4 are cat and 1 is dog. So KNN will say in 5 nearest neighbor of this, 4 are cat and 1 is dog. Based on the majority, this particular animal is cat. So this is the learning using the training data and then classification using the training data of the new test data. This is how KNN works. Okay, now I will just, because for training or for teaching KNN, I have these many number of slided, I have lots of examples. So it is not possible in this 1 hour lecture to give full detail of that. Maybe like I also give one example of SVM. This is a course I usually teach in my student, which I call it as machine learning course. So support vector machine, it was proposed by Vapnik in 1992. It is one of the most famous classification method. What it does, it try to learn a line which classify the data set of 2 different classes, and there are several such lines. What it does, it learns a line which has the maximum margin between the 2 classes if the data is separable. Separable nahi hai, then if they are not separable, then the thing is different. But if they are separable, then it learns a line which has the maximum margin. So they have lots of constraints, like all the data point of one class should be above this line and all the data point of another class should be above this line. At the same time, we should have the maximum margin. So if you have the basics of optimization, we have some kind of maximization problem, maximize this margin with these constraints, or minimize this mathematical value, which is nothing but the margin between them, and try to fulfill this constraint. So then there are lots of optimization methods like sequential optimization or least square regression, and all those optimization methods are there. The methods are applied using the SVM, and finally it gives you a plane which distinguishes or which classifies the data into 2 classes. But there can be the cases where the data is not linearly separable at all. So it try to have minimum errors, like this white point is on the other side and this green point is the other side. So there is no possible line which can give 100% accuracy on training data. So maybe like what they do, they try to have minimum error, at the same time try to maximize the classification accuracy. So this is how it is doing. And one thing we should remember is getting the 100% accuracy on training data is not our aim. So one should not try to learn this kind of SVM. Okay, so this is called overfitting. Overfitting means on the training data you are trying to fit a very complex curve, but this is not, this does not have the generalization capability. This is missing generalization capability. Generalization capability means you are having only 100 data points, and on those data points you are trying to fit such a complex model, and the complex model is kind of trying to overfit, and it's a very complex in nature, and it is not generalizable to the new data points that will come. So instead of this, maybe we would have used, if we would have used this particular plane, maybe if we would have used this particular line, a simple curve, this is a better SVM. So in SVM also we have the complexity or the polynomial order of the curve that we want to fit, maybe the second order curve or a third order fit curve. So we should not have a very complex curve. So this is a better way of SVM, which has got better generalization capability. So there are a lot of terms involved in machine learning, and I would say the machine learning is not for computer science people, for electronics, for electrical, anybody who knows the basics of probability who knows basic mathematics, even if it is a 12th class student, they can use machine learning because it's just a simple classification methods which use simple mathematical tools. And even if you are not understanding the mathematics very much, there is a famous person who works in the machine learning area is called Andrew Ng, if you know the name. He's a professor. He has developed lots of machine learning and deep learning tools in Python. He says even if you are not able to understand mathematics properly, you should not worry, because you will get or you will understand them later with the time. And there are a lot of tools available in MATLAB as well as in Python for machine learning. There is a proper machine learning and deep learning toolbox in MATLAB as well as in Python. You can import the libraries like in pandas and keras and all, and you can do the things. So like I am saying, in SVM there are a lot of things that are being done, but even if you do not know them, you can just use it as a tool. Okay, so there are some examples of pattern recognition task. In this example, there are patterns of images of numbers, and the class is to identify the numbers. So maybe the features. So first of all, you will have to take each image RGB, then you have converted into binary. Binary means only two color, either black and white. Then you crop the image, then you take some kind of features, and then, so this is some GUI, graphics user interface somebody has made. So it will be able to recognize the number. Okay, so there is one famous data set. It is called MNIST data set. I will just give you here it. MNIST data set. So if initially you want to learn, it's a MNIST data set of handwritten digits. So this data set is available. A lot of images, like these are training set of images. These are the test set of images. So you can use some machine learning method. And they are also providing this particular method has published this paper, and with this much accuracy they have produced the results and all. So you can download that data set and you can classify the images or test your model that you have built. In pattern recognition of, say, audio, in this the features were like moment, means, median, mode. Like you are having this some pixel values. So you can take the average of the pixel values, you can take the median, mode, histogram, gradients, all kind of features you can use. In audio, the features to be used are like chunks of speech, spectral coefficient, and all those things. You can recognize the speech. Fingerprint identification. So the pattern is image plus an identity claim, which I do in my mobile. The class is yes, it is you, or no, it is not you. Position of minutes, orientation, field of ridge lines. Basically, these kind of lines are used as a feature. Document and a query. Like on website, I search like, for example, this is Google, and I search here India. The class is the relevance. So most relevant answer is India, Wikipedia. The second most relevant, they are giving the YouTube results. Maybe I go to the images. So you see these kind of results are coming. So the most relevant ones come the first, then the second relevant one, and all those kind of happens. So this is one of the example where the class is the relevance or not in general rank, features, word occurrence, counts, word context. So where you are writing and all those things. This is very useful in spam filtering and diagnosis of machine. When you see your Google, your Gmail, if you see your spam folder, there will be a lot of messages of you are winning a lottery of thousands of crores and all those things. Google knows, and they are keep on learning which kind of message can be spam, and then they filter it out to the spam because of occurrence of word counts and all those context of the word, and based on that. So these are examples of pattern recognition task. So there are basically categorization of machine learning is basically of three kinds: supervised, reinforced, and unsupervised. It is like a teacher is teaching his student. In the supervised learning, teacher gives the true class level for each feature vector. Like in this, I told the student these all blue and all red are the features from two different classes, and red ones are dogs and blue ones are cats. I every time teach my students, say this is a word A, character A, this is B, this is A, this is B, this is A, whatever way you can make it. So all these are different patterns. This is one pattern, this is another pattern, this is another pattern, but they all of them belong to class A, and all those belong to class B. So this is what I am saying that to them. So this is supervised learning. Whenever you have the feature vector and the class levels to them, that is called supervised learning. There is one thing called unsupervised learning. No teacher is involved. A teacher does not give any information. So they just said, they will just tell you, these are the patterns, and try to group them into 2 different classes. So maybe you will be doing natural grouping of this is one group and this is another group. So this is also sometimes called as clustering or segmentation or natural grouping. So this is called unsupervised classification. For example, on YouTube, you just upload a video. You do not give a category whether it is a cricket video or whether it is a comedy video. But when you will be watching a comedy video or maybe watching a cricket video, you will see in the side menu bar a lot of cricket video will come. So Google does the kind of, or YouTube does kind of clustering of the videos and give you the answer in terms of those. And there is one more kind of learning, it's called reinforcement learning, where the noisy assessment of the performance is done in terms of correct or incorrect. So if you are correct, it will say it is correct. If it is not correct, then it will say incorrect, but will not give you the class. And it is not unsupervised as well. For example, automated car driving cars, when they are trained, they are going on the road and maybe suddenly they collide with other car. So they will understand because my speed was more, or because I came in the very narrow range of a vehicle, that's why I collided. So based on that kind of learning is called reinforcement learning. So the machine learning is broadly categorized into 3 areas: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is again classification and regression. So regression are different things where we try to fit the data curve on data on the curve. So classification are used for diagnosis, customer retention, image classification, identification of fraud detection. Unsupervised learning में clustering and targeted marketing, recommendation systems, customer segmentation kind of thing. So like a bank is there, State Bank of India. They try to find for which customer I should sell the credit card, for which customer I should say the home loan, for which customer I should sell the other kind of loan. So customer segmentation used. And then reinforcement learning is for gaming, AI, real-time decisions. A lot of application. These all includes every field of machine learning. So this is a big slide. If I will try to explain it, it will take around 1 hour to explain this slide. So any doubt at this point to anyone?
No, sir, just simple general questions, I think here. For binary code are scripted in fingerprints or thumb impression detection. So if it is relevant to this, then we can discuss here. Otherwise, we can do it.
Scripted in fingerprints or thumb impression detection. So if you try to distinguish, if you want to distinguish between the fingerprints, okay, so there are a lot of features which are related to fingerprints, like ridge lines and minute orientation of minute lines. So if you are going to do research on this, maybe you will have to first read 2-3 papers on that, and you will understand which kind of features they are using mathematically, how they are calculated from the images. Basically, they all are images, but some kind of like Huff transform is for line detection. There are several detection methods. So you will detect those edges and ridge lines, and then you will be using like sometimes in audio we will using feature like for audio range we will be converting the signal to the audio to frequency domain using Fourier transform, and sometimes we use wavelet transform. So similarly here very specific features are used, minute of ridge lines and all those things. So being specific to thumb fingerprint recognition, you will have to first read all the documents or few documents which features we have to use. I already told in one slide the features to be used are problem specific, and there are a lot of problems you can see in this slide. If it is a problem of customer segmentation, you will be trying to find what is the salary of a customer, how much is the monthly expenditure, how much time he pays his credit card bills, all those things. But if it is a problem of a diagnosis from medical images, in the medical images, whether there are white patches or black patches, these are things to be used. Image classification of cat and dog, we have seen an example. So there are a lot of different fields of research, and one cannot be expert in all. I mostly work in diagnosis and also in automatic traffic sign recognition and all those areas I have worked. Because BTech student, when I guide, they every time come up with some new research area. One student worked with recommendation system. So in recommendation system, what did they do? If you want to buy something, like you want to buy a phone on Amazon, you just type a new mobile phone. So based on your past history and based on your expenditure, it will recommend you a phone maybe in the basic phone range of 5,000, maybe a 20,000 phone, maybe a 50,000 phone. If you are going to buy shoes, it will recommend you maybe a shoes of 300 rupees or maybe a Nike shoes of 5,000 rupees. So this recommendation system works on your previous history and your other experiences. So the features you can see are very, very different in recommendation system. Features are very different in the diagnosis of images. And so when you are going to do mastery in one thing or you are going to do research work, then you have to at least go through several papers. If you are doing a BTech project, you can read 1 or 2 papers and try to understand what kind of features I should be using for that. Okay?
Sir, excuse
Does
me,
this
sir.
clear the doubt?
Shall I ask one question, sir?
Yes?
Sir, actually, with the reinforcement learning,
Yes?
when we apply reinforcement learning, in the applications, there are some randomness. So, how can we be confident about applying reinforcement learning, sir?
Ma'am, if I speak to you frankly, I just know what is reinforcement learning.
Okay,
But
sir.
I have not worked much on reinforcement learning. Most of my work is on supervised as well as unsupervised learning.
Okay, sir. Okay, sir.
So I have not much idea about the reinforcement learning.
Okay, sir. Okay, sir. Thank you so much, sir.
Okay, there is one question. What is the main difference between deep and machine learning? I thought these are BTech students. So deliberately, I removed lots of the slides from my original slide. I will just go to the original one here. I removed lots of slides when I sent it to you. I also had these slides how Industrial Revolution 4.0 is being affected by machine learning. This was my research area, which I was saying. A person is seeing something and we are trying to operate lots of devices like phone, mobile, and all this. Recently, I have supervised one PhD on this. So I will just give you the difference between deep and machine learning. Okay. So if you are talking about machine learning, you have the input image, you handcraftedly picked some features. Features like you picked length of the car, how many number of wheels are there, what is the size, and all those things. So manually you picked a lot of features, and there is a classification method. This is an example of neural network, and it will learn from those features. So features will be the input values. Each feature will be one input. If you have 10 features, so this layer will have 10 number of such nodes, which are called neurons. And this will have 2 output neurons. One is for cat and one is for car and one is for no car. So this is machine learning. In deep learning, you give the input as it is to the model, which is called deep learning model. You need not to pick the features yourself manually. Like I was talking, that features to be used are problem specific. But now these deep learning methods are being designed, which captures almost all kind of features, and they find which one is relevant and not. They go in the depth of the image and keep on finding new features. So the feature extraction as well as classification, both are done using the deep learning model. So this is the more preferable because they are new models. If I strictly speak, the machine learning method become famous in 90s, but the deep learning concept was proposed even in 1950s. Neural network was proposed in 1950, but the kind of computation they need, that kind of computation was not available because there were no computers. Even if there were computers, they were not very smart and fast. So the deep learning was ignored. The mathematics of it was ignored. But when the supercomputers, or nowadays we say GPUs, graphical processing units, and very high RAM species are available, the deep learning mathematics are now being useful. And instead of machine learning, most of the people are using deep learning, like convolutional neural network. So the important thing here is you need not to extract the features. You just pass the images and get the output. The disadvantage is you must have a lot of training data set. Here even a small data set of 100 images will work. Here you will need thousands of images for training. It is something like if you want a very simple task, if you want to kill a mosquito, you can kill by your hand. But if you want to kill a lion, you need a bullet or maybe a banduk. or maybe something like that. Okay, AK-47. So if you want a small task, you do it using machine learning. Like if you want fingerprint recognition, a machine learning will work well. But if you want a very high complex tumor detection problem and all, you need to have a deep learning model. You will need a lot of data set. You will need a complex model which will be trained using high computation requirement, which will need a high computation requirement. You will need a GPU for that, and you can do the deep learning. But if you want to publish research in a very complex problem, you should prefer deep learning. So in deep learning, first they will have a lot of filters, and they will be like in DIP, they will be moving over them, and then over those whatever information is coming, you apply linear rectifier unit, you use the pooling, then again same kind of thing. So lots of things are in the depth. So maybe, for example, from the face of an image, face of a person, in the first level you detect these kind of things, maybe circles, maybe a line with 90-degree or 45-degree or 125-degree orientation. Then maybe after some depth information, you will be able to detect the eyes and nose and mouth, and after several levels of layers, you will be able to detect the faces of a person without using the features like what I was saying. So the deep learning basically in the first level detects very basic information, and as soon as you go in the depth by using same kind of features, you will be able to detect the complex things. But as I already told, it requires a lot of computation. It requires a very high computational capability computer and a lot of training data set. Okay, this I am not covering here. Generative adversarial network, that is something different. Any other doubt here?
No, sir. No questions in the chat box. We can move.
So can we have a 5 minutes break before I can start the MATLAB session, so that people can also start their MATLAB if they want to continue with it? Should we break for 5 minutes? It's 7 o'clock. We will start at 7:05.
I think participants have the systems with MATLAB. If you have any queries, then you can ask here. That will be a 5-minute break. Will it be okay, sir?
Sir, actually, we need database if we have to work on it.
Okay, ma'am. So what I will be doing, I will be just demonstrating using some data set, very small data set. I have given the data set, a small data set to sir. It is in KBs. You can do it later. I will send the MATLAB code as well to you. So you can write your own code, and or otherwise you can use the code on the data set. So in WhatsApp, I shared with, if you will see this, with sir.
I have already shared, sir.
Yes, 2D zip data set to
I have
assign.
already shared in group.
Okay, so that you can use later also.
Okay, sir.
So we will start in 5 minutes, okay?
Sure, sir. Shall we keep the font size as bold, sir?
I have not done it bold, but I have increased the font size to 16. Is it visible, or should I increase it further?
The increment is not required, sir. If it is bold, then it will be easier to watch. Yes. Yes, sir. It's okay.
Okay.
Thanks, sir.
So maybe after 5 minutes we will start. Okay, sir.
Sure, sir. So participants are requested to turn on their laptops with their MATLAB. So simultaneously we can have a practice if the time permits. or if you have any query regarding the previous 1 hour, you can write in chat box. We can have a discussion at the end of this session.
Okay, everyone. Welcome back. Have people? Am I audible to everyone?
Yes, sir. Audible.
Yes, sir. Audible.
Okay. So let me show you one slide. Suppose you have some input. Suppose you have some input patterns. Okay, you extract the measurable features. So measurable means whatever you can measure in terms of numbers. You are not going to say that I am going to measure the emotion of a cat or dog. You are measuring the length and height, whatever you can measure. And from that, you will get the feature vectors. That feature vector, you will have to decide or to divide into test data set and training data set. So that will also somebody not will do for you. You have to decide from those 1000 images, maybe I am going to keep 500 for training or 500 for testing. There are other methods of dividing the data set. So maybe you have some kind of data set. Then using the training the data set, you will have to train the classifier. So your classifier is now ready. Using the classifier, you have to give the test data as input in the classifier and get the output classes. And you will match how many of the classifications or how many of the classes the classifier has correctly determined. Okay, so then that is called accuracy. There are other methods of measuring the effectiveness of the system. That is called true positive, true negative, false positive, and false negative. So the actual class may be positive or negative, and predicted class using the classifier can be positive or negative. If the actual is positive and predicted is also positive, you call it as true positive. Like say example of we say there is an RT-PCR test for COVID detection and there is an antigen test for COVID detection. So the actual, if you're actually having COVID and the RT-PCR detector is positive, you call it as a true positive. So people say that RT-PCR's true positive rate is high. That means it is very effective in determining true positive, whereas antigen is not that much perfect. Even if you are actually positive, it will detect as negative. So that is called false negative. You are positive, but it is detecting as negative. It is called false negative. Okay, so negative is the answer, but it is false. Prediction is incorrect, false negative. Then if it is actually negative, and it is also predicting actually negative, it is called true negative. Okay, you are not having any symptoms, it is not detecting any COVID, so it is true negative. Same things with the classifier. If it is detecting the plus class for the plus data, it is true positive. It is detecting negative class for negative, it is true negative. The otherwise case is called false. So for the negative class, if it is detecting positive, it is called false positive. And if you have heard the doctors, they say false positive is not a big issue. If you are not positive and it is detecting positive, so that is not harm to the society and not even for you. It will detect you positive. Maybe you will take some of the initial pills, but after some time you will feel I am okay, and maybe you are in the isolation. And also false positive is not going to harm anyone, but false negative is going to harm a lot of people. You are freely roaming assuming that I am not COVID positive, but actually you are positive. So false negative rate should be low. But sometimes, depending on the problem, sometimes false positive rate should be low. So using this, you want the accuracy to be good. You want true positive and true negative to be good. True positive divided by total, which were actually positive, is called sensitivity. You want the sensitivity to be high for true positive to be high. You want the specificity to be high for true negative to be high. And the average of both is called accuracy. And overall, this particular table is called confusion matrix. It is not confusion matrix because it confuses you. Just the name is given confusion matrix. Okay, so now we will be going to plot a two-dimensional data. Two-dimensional means there are only two feature sets, or there are only two-dimensional features, and there are two binary classification problem. One class say 0 or 1 or +1 or -1, whatever number you want to give, that is a binary classification. Then we'll be applying a support vector machine, SVM or k-nearest neighbor classifier for supervised classification. So let me go to the MATLAB, and I'm going to this assignment 1. Just I will show you the data set. So I have got this data, train data. Okay, so if you will load it, you will see this is my first feature, this is my second feature, this is the class. So this is feature vector x1 and its class y1. Feature vector x1 has two features. First value is 0.9, second value is 0.16, and the class is 1. The second feature vector x2 is having -0.5, -0.15 as feature values, and this is the class. So like that, I have got 100 feature vectors. Okay, like this, I have got 100 feature vectors with different classes. Some of them are +1 class or +1 class, and some of them are 0 class. Okay, so if you see, so these are the list of HTTPs where I have already presented lots of work. So this HTTP of ML. So maybe this was assignment 1. We have two class. That means there are two classes, 1 and 0, two-dimensional data set. So here you see there are two classes, 0 and 1, and these are the two dimensions, first dimension and second dimension. Set containing 3 training data files. So there are train 1, train 2, and train 3 data file, and 1 test data file. Some of them are noisy, some of them are not noisy. That we will understand later. Import train 1 data file and plot the data points according to their respective classes. So this is the task 1. Okay, so there is a function in MATLAB. I have also given you the list of functions which are useful: import data, plots, sprint, subplot, help, CLC, clear, hold, figure. Okay, so I have just cleared all the previous things. I just write clear all. I assume that after 2 modules, you all know the basic functions of MATLAB. Is it okay? Any response?
Yes, sir. All the topics have
Okay,
covered.
sir. Okay.
So if whatever I'm writing, I think you are able to understand, you know, this is called current folder, this is called command window, this is called a workspace, and here from here you can create a new script file or function file and or a class or something like this. So I have just created a new script file. Okay, I just written clear all. Then there is a function called import data. Inside the bracket, you have to write the name of the file. So there is one file, train1.data. So I have written train1 or train3 or train1.data. And you have to write this within these brackets to read it. So I just explain code line by line. So you have imported the train1.data. So I just, if I remove all those codes, I will comment it out. So this green means comment it, it's just a comment, it's not going to execute. So I run this file. So what happens after running this code, it will import the train1.data file and store it in this variable. So I call the variable train data. So this is how the variable is looking like. It has having 3 columns, 1, 2, and 3, and 100 rows. The first column corresponds to first feature vector, second column second feature vector, or I can say the 2 columns are the features, and the third column is the class level y. This is the first feature vector, second feature vector, and there are 100 feature vectors. Any doubt in this? Any doubt to anybody in this?
You can write in chat box also.
I will share this. Okay, if you want, I will do this. Are some people going to execute simultaneously? I just want to know. Anybody?
Doing, sir.
If you're doing, then it is good. But I think not many people will be doing. Okay, for first 1 or 2 tasks, we will be doing slowly. Then for the later task, if you will try to follow with me, it will be very kind of very time consuming, and you will be not able to get all those things. So for first task, maybe you do with me. Then from second and third, just see what I'm doing. Okay, so can now somebody tell me what does this line mean? X is equal to train data, this column, and this 1, 2, and this. Anyone?
First column and second column we have to consider for x. X is the value, that is input.
Yes, madam is correct. All the rows, this means you can also write row number 1 to 100, but when you are taking all of the values, you just can put all the simple way, just column. Row number 1 to 100 and column number 1 to 2, I am calling feature vector x. So you see this, row number 1 to 100 and column number 1 and 2, I am calling it as feature vector. So this, if you are going to include all, you can simply write simple column, starting from first to last. So if I run this code again, you will see in X, you have the same thing, but only the first 2 columns and the third column is not there. Okay. Similarly, you want to have Y. Y is my class level. So Y is equal to train data, all the rows, only the third column. So if I run this code, you will see Y will have only 1s and 0s. That means only the class level is there in the Y. Remember when I have shown you this note, then I have told that we have a lot of feature vectors. We have 100 feature vectors and we have 100 class levels, where each class 1 will be 0 or 1 and each is a 2-dimensional feature vector. So this is it. Now, this line of code, line number 5. Can anybody explain me what is x1 is equal to x, where y is equal to 1? Line number 6. It is a self-explanatory kind of thing. This is a check. If we all have gone through the C language, if we have double equal to, we are checking something. So we are checking if y is 1. If y is equal to 1, for all those rows of X, we are having basically the feature vector of class 1. Is it clear?
Yes, sir.
Okay, so is it becoming boring for people?
No, sir. No, sir.
Because there is one more faculty like Dr. Atul, he told me that this workshop is on MATLAB, so you try to include some hands-on in MATLAB. So that's why I'm trying to include, but nobody is responding, so it looks like.
Sir, okay, sir. Yes, sir. We are listening.
Okay, ma'am. So this line says in X there are 100 points. In X1 we are going to copy only those X points where Y is 1. Okay, so that I am calling it the first feature vector, X1. So if I run this code, so you see after running this code in X1, I'm having the values corresponding to Y is equal to 1. I'm having 47 feature vectors. So basically there are out of 100.
So you have separated the classes for class 1 and class 2.
Yes, class 1 and class 0. So for class 1, I have written this line, and for class 0, I'm going to write similarly x0 is equal to, so I have given two variables, x1 and x0. x1 is the value where y is 1, and x0 is the value where y is 0. So obviously, if there are 47 vectors in this, there should be 53 vectors in this, because total vector should be 100. So if you see x0, it contains 53 vectors, whereas x1 contains 47 vectors. So 47 vectors are for class 1 and 53 vectors are for class 0.
Why you have separated like that, sir?
I will tell you other method where you need not to separate, because I am going to plot them according to their class. If you see this figure, the cats are plotted using a circle, red color, and dogs are plotted using a cross.
So, okay.
That without doing that also you can do, ma'am. That I will tell you later. So I am going to use this function called scatter. So scatter basically scatters data in this way. Two-dimensional scattering of 3-dimensional. So scatter x0. Okay, x0 means all the class 0 data point, its first value versus second value, first column versus second column. So if you see, the first column is the first feature x1 and second column is the second feature x2. For example, if I just go here, so this value is minus 0.53 and this value is minus 0.15. So what it will be doing on the axis line, it will be marking this and then making a point at that particular place. So like that you can put the first point, then second point. So for all 53 points, it will be doing the scattering. So if you go back to the code, you are going to scatter all the rows, first column versus all the rows, second column. So this is the function, and figure means it will generate a new figure. Okay. So if I run this code, after explaining this, I will share this whole code on this chat. You can do. So what it has done, it has plotted all the class 0 points, all 53 class 0 point, which is ranging in this particular -1 to 1, using the blue circles. Then this function is called hold on, which will continue to hold the figure, and you can again scatter the other class. So here this Rx means it will be plotted in red and it will be using the X marker. So how I know this? So I will just write help plot. You see this. I'm going to maximize this screen. So in MATLAB, you have the lots of options. You can plot in blue color, green color, red color, cyan, magenta, yellow, black, and white. Basically, this is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0. Like this, the combination, that binary combination of 3 bits, 1 to 8. You can plot using point, circle, marker, plus, star, square, diamond, triangle, up triangle, left triangle, right triangle, pentagon, hexagon. If it is about line, you can have a solid line, dotted line, dash dot line, dashed line, and all those things are options are there. So first default was blue circle, which I did not give any option. So by default it plotted like this. And the second class, it is plotting like Rx. So I run this code again. Now you see it has plotted both the classes. Okay, so now I share this code with you, and if you see whether it is running in your PC or not. Sometimes it may not work if you are using an older or newer version of MATLAB, depending on that. Sometimes for older version, instead of scatter, you should use the function called plot. And maybe in the newer version, you want a different function. Is it working for anyone?
Yes, participants, if you are copying it and executing it, please write in chat box whether
And
it
if
is
you are
working
not
or
doing
not.
it, then we can ignore this, and I will explain the other part of the code, because if we will go do all of those things
So
by
for
your
me,
hand,
it's I am having error, sir.
what is the error? Can you tell me?
Import data, line 139.
Okay. So
Unable to open the file.
So when you are having the current folder where you are saving that particular function, you should also have your files in the same folder.
Yes, sir. I'm having the same.
Maybe then you are missing these parentheses or maybe something like that, because if you are doing that, that problem will come. So wherever, or what you can do, madam, wherever you are having that particular, for example, I will just give you an example. Suppose you are here, you are having these information. So you copy this particular address from here. Just click it and press Control C and copy it, and then go to MATLAB and Control V here, paste it, and then enter. You should
Okay,
be able
sir.
to see. You should be able to see these files here. If
Okay,
you're not
okay.
able to see, then it will not work.
Okay.
Actually, with participants, I shared the zip file. So using some unzip function, you first have to unzip it. Like this, there is one function I have unzip it and extract here. You will extract, then these files will come. And when you are working in MATLAB, you should be ensured that when you are running this particular function, this particular file should be in the same folder. Or otherwise, you have to give the full address of where it is stored.
Sir, about half an hour left, so
We can do, sir.
I think
In
we
half
can.
an hour, we will be able to do.
Yes, sir.
Okay.
There are 3 responses that they are working. Their responses, their code is working.
Okay, so if you have some problem, you can share with me later on your screen or your. I have sent my Gmail address, or in WhatsApp also. All of you can write, and I will tell you how to do it. Sir is correct. Lots of other assignments to be done. So maybe okay. I will show you. Make a function to import one of the 3 training data files and plot the points according to the respective classes. Import test data files also and plot it over the training data. This is the second task. So I will show you in my task 2. So I have written a function file. So remember, the function file should be this file name task.shoot should be same as the function name. So the function name is task2, then the file name should also be task2. How I can do it? I can write here new function file, and whatever name of the function you want, you write like task_2_FTP. That is okay. If there is some input argument, that is okay. If no input argument, then all you can read. So maybe I can write n, and there is no output argument, so I'm going to delete it. And you can write the description of the function. I write n is equal to 1 for file 1, then n is equal to, or I can write n is equal to 1 or 2 or 3 for file 1 or 2 or 3. Okay, then I will write the code and all. And when I Control S, save it, your name should be same as the function name. This name you cannot change. If you will change this name, the function file will not work. Okay, so I saved it. So what I have done, I have again imported data using a function called sprintf. What sprintf does, if n is like %d, we have write printf in MATLAB. In C, we have printf function, and printf value of the variable is equal to %d comma n. So it will print the n. So if n is 1, it will use the train 1 dot data. If n is 2, it will use train 2 dot data. If n is 3, it will use train 3 dot data. So just one of the 3 training data files will be loaded. Then you have the train data function, train data file. So you copy the first 2 columns to the x vector and third column to the y vector and plot. Now you see, what is the disadvantage of this first method? You are having x as a 100-dimensional vector. Now you divided them into this. This is having 53, this is having 47. So you copied 100 into 100 more places. So now you have 200. So when you have 1,000 or lakhs of images, you cannot afford to copy them into another one variable, because otherwise your space will be less, or maybe it will say running out of space. So instead of that, I used the logic here only, plot x for y equal to 1 and versus x for y is equal to 0. So this was the first plot which I did. Plot x for all y equal to 1 with blue color or circles, plot x for y is equal to 0. So that 2 lines I have merged into one. First I copied this into x1, then I copied it into y1, x0, and then I plotted and hold on. So instead of that, what I have done here, I have copied in a single line and plotted. And now I am using the import data function again to load the test data file. So this is the test data file. And again, dividing into x test and y test, where the first 2 columns are the test of x and y is for this, and hold on and plot it. So if I run this, so I'm getting this. Okay, there is an option in MATLAB which is called insert legend. Actually, okay, that earlier thing was there. Let me clear it all. Clear all. CLC. Then I run this function task2. Task function you have to call from somewhere with a value of n as 1. I run this. So this is it. Insert legend. You can insert legend. You can write here whatever you want. So basically you have got, if I without doing the second part, if I just plot it, you will try to understand what is happening. So I commented this out, Control R. Now you see. So if it is quick, let me know if something is not. So this is the first plot I have done. I have plotted the training data of class 0 as red, as in class 1 as blue. Then I did hold and I loaded the test data as well here. So I am going to uncomment it. I loaded the test data and plotted using green color X mark as class 1 data and black color plus as another data. So if I do this, you will see. So this black and green are for the test data and this blue and red are for the training data. So anything you want me to explain? Anyone?
No, sir. No queries in chat box.
Suppose
Okay.
I have, sir, only if you have 2 columns, then okay. If you have more than 2 columns, or suppose I have 4 columns, sir, in that case, input
What?
data.
So then, ma'am, in that case, if you have more than 2-dimensional data, you can do the classification, but you cannot visualize it using a plot function. Okay.
Yes.
So visualization is only possible in 2-dimensional data. Even sometimes in 3-dimensional data, it is also possible. Okay. But in more than 3-dimensional data, you cannot visualize the data. You can do the classification, you can get the result.
Yes, sir. Yes, sir.
But you cannot plot it. So this plot thing will not work.
No.
Okay, I will explain it. Now I'm going to quickly, I'm going to assignment 2. And let me show you what is that assignment 2. First of all, you should ensure that in MATLAB, whatever you are working, that should be there. Okay, this is the assignment 2. This assignment 1 we have done with the help of those functions. Assignment 2 is, we will use the 2D data same as in assignment 1 for this assignment. Using one of the training data set, train the SVM classifier that separate the two classes, classify the test data set using the SVM classifier, compute the classification error and confusion matrix. Okay, so I also give the hint that you have to use the function called SVM train, SVM classify, confusion mat, fit CKNN, predict, and PCA. PCA, I'm not going to do this, or yeah, other files, import data, plot, as printf. So just let me do one thing. In MATLAB, there is a function called help. Help SVM train. I just run it. It will tell me whole history or whole logic of how I should be applying that function called SVM train. SVM train, so you have to pass the training feature vectors as I stored in X and Y as the class level. Trains a support vector machine classifier of data taken from two groups. It should be a binary classification problem. That means Y should be 0 or 1. Okay. So this is an example. Kernel function means whether you want a linear line, you want to pivot, or quadratic function, or polynomial function, or these are some other things.
This SVM classifier is a binary classification, you said, no, sir? So
Yes.
it can be used only for two classes.
SVM can be used
For
only
more
for two
than-
classes. Yes, ma'am. Neural network can be used for more than two classes. KNN can be used for more than two classes. But in SVM, there is a method called one versus rest, or trying to do in a hierarchical way. First divide in two classes, then again two more classes, like that you can do. But at a time, it can have only one line that can separate the entire set into two sets.
But comparatively, this is very time consuming, I believe, sir. When I worked with this code, SVM was quite taking the time much.
Multi-class SVM also available, sir. Is it not?
It is available, ma'am, but by definition and by logic, it will be breaking down the code into smaller, smaller SVMs, which will be doing the binary classification, and then it will be giving you the final answer that you want. So mathematics, in mathematics, nowhere you will find a multi-class SVM. It is just a binary SVM, but in MATLAB, they designed a code in such a way that divide the data set into one versus rest. So they implement in a way that first to divide the data set into one versus rest, it is called one versus rest, like class 1 versus the rest of the classes, class 2 versus rest of the classes, class 3 versus rest of the classes kind of thing. And otherwise, they have the hierarchical classification. First class 1 and class 2, then again class 1 is divided into two more classes, or class 2 is divided into two more classes. Like that it can be done. But logically, it is only a two-class classification which learns a line. But ANN, as many number of output layers node you have, those many number of classes will be there. Okay. So these are other options. Show plot if you want to show plot, and alpha and bias and all those things. This is a small code written where you have the X feature vector, you have the Y class level, and this is also called CV partition, a cross validation partition. What you do, 20% of the data you hold for the testing randomly. So out of 100, maybe 20 randomly images you taking for output. If you are not going into that, simply we have the training data and test data. So I pass X and Y and just write show plot true. So if I just copy this code from here, which is there in the SVM train help, and see here, I just write a code, import data. So I imported the data. Sometimes you need not to copy the data into your folder. It is a kind of very cluster, very like if you see this, if you also have a lot of data set here, it will be very difficult to find where are the function files and where is data. So data can be in a separate folder. If it is like that, you have to pass the address like this, assignment to 2D data. So you are passing the entire address and then the training data file. So it will go to that location and then will load the data. Okay, then again you divide it into xtrain and ytrain. Xtrain is the training data set and ytrain is the corresponding class. Similarly, you loaded the test data set and you have xtest and ytest. Xtest is the test data set and ytest is the test class. So I cleared not required data set, clear test, clear train, clear number. So till here, let me just run the code. So I got very neatly, I got xtest, xtrain, ytest, ytrain. This is the training data set with its class level. This is the test data set with this class level. Any doubt in this? This is commented out. Green one is commented out. Using Control R, you can comment all the line at a time, and using Control T, you can uncomment. Okay, so this is the function SVM train, where you have to pass xtrain and ytrain. Very simple code.
So there's a question in chat box.
What?
There is a question by Kapil Gupta ji that sir, can we use the same data set for testing and validation?
If you will do it, will not be useful. It will not be useful in the sense whatever you have used for training, even after training you will be able to see what accuracy it is giving. And okay, just let me explain. In this figure, this is my training data.
Testing and validation same or different, sir? Actually, first of all,
okay, testing and validation. Normally, people use testing different data, validation different. That's why the word. Otherwise, most of the time you can also kind of ignore validation. So some people just do testing and training. So if you use same data for testing and same validation, it will not be very effective. It will not be called effective. Okay, I was thinking about training and testing the same data. Okay, so training and testing obviously should not be the same.
Why you are saying like testing and validation? Is it same or different? That's what I want.
Testing means, so ma'am, like test
by definition is not a testing.
Definition is little different. Training and testing, after testing you are satisfied with your model and you are throwing it away like some kind of like my model is ready and it is giving this much accuracy. Then you will try to validate whether it is as much effective on the novel data set or not. So generally what people do, say when they are having 1000 data points, that 1000 data points they will be dividing into training and testing part using some cross validation or CV partition. Once the model is ready, a new validation data set will be used for validation of your entire model. So there are some other logics also. Some people write in a different way, but this is what I have been taught during my work. I did a formal course on machine learning as well as pattern recognition in IISc Bangalore. I did my MTech in system science and automation. So that automation word taught me the subjects like digital image processing, machine learning, pattern recognition, and all those things I studied in 2009. So at that time, these were very initial level of courses which were introduced in that institute. Okay, so I have xtest, xtrain, ytest, ytrain. What I'm doing, I'm going to comment this out. I'm going to xvm train using the xtrain and ytrain and just writing show plot true, and kernel function I am going to write linear. If you do not write this, it is okay. Just let me run this code.
So how many data you have taken for test and train?
That 100 test training data.
Percentage in terms of percentage.
Just a minute, ma'am. So this is how the learning is happened. Class 0 data and class 1 data, and these are called the support vectors. This is something related to the classifier. Okay, so the question is how many? So I just have a test data files of 100 of the points and train data file of 100 points. So I'm not going to here do the thing which I was saying that having 1000 you have to divide. Here in the assignment, if you see, you clearly have train data file and test data file. So train data file we are using for training and test data file we are using for testing. So if I go here, this 2D data, I'm using one of the train data file at a time for training, either train 1 or train 2 or train 3, and the test data file I'm using for testing. Okay. So I'm not going to mix them and then divide them. I have separate files for training and testing in this assignment. Otherwise, you can use CV partition. So this I have done.
Normally we use 80-20 or 70-30 like that only, no? That's why I asked.
That is, madam, not preferable nowadays. If you write a research paper, they will say do not do that. Use CV partition, cross-validation partition. I will tell you what is cross-validation partition. What it does, what that method does. Suppose you are having 1000
I used a five-fold cross.
Yes, you have 5-fold cross-validation.
Yes.
So what it does, you have 5 different folds.
You have to repeat it.
So first fold have randomly selected 200 points out of 1000. Then the 800 points are remaining. Out of that, 200 are randomly selected. Now 600 are remaining. So like that, they have got 5 folds. Fold 1, fold 2, fold 3, fold 4, fold 5. Then 4 folds, first 4 fold will be used as a training data, and 5th one will be used as a test data, and you will get the accuracy. Then next time you will be retaining this one for testing, and F1, F2, F3, and F5 for training, and this one for testing, and you will get the accuracy A2, like A3, A4, A5. So this way you will be using at around 80% data for training. They say you should use as much data for training as possible, and rest of the data, all of the data has been used for testing. But the disadvantage is you have to repeat the process 5 times of training and testing, and then average accuracy will take. So you will be getting 800 data for training, and you will be testing your data, your method on all 1000 data sets, but after repetition of 5 times. So this is generally preferable. Okay, so you have done this SVM train, X-train, Y-train, show plot true. Then what you are doing, you're using this SVM struct. In the structure, you have the values related to SVM, that kernel function is linear, and bias value was this, and alpha was this, and these are something very, very much specific to SVM. So you have got that structure. That structure now you use to classify the data of X test. See, in this line number 20, you are not passing Y test. Y test is the class level of the test data, but you are not passing that information. You are just passing the feature vector, and you are asking the classifier to decide the class. So it will decide the class in a vector called C. So I just run this code. So it has got all the things. Let me just show you. Instead of linear kernel, if I use some other kernel like RBF kind of thing like that, so what will happen? It can also learn a non-linear classifier. So this is a non-linear classifier. Training data of 0 class, classified data of 0 class, test data of 0 class, class 1 data of 0 class, and this is a SVM. So this is all what is being done by the classifier, and it has given me the class levels in C. This is my C vector, and this is my Y test vector.
Sir, you have used the kernel, linear kernel, right?
Now later I used RBF kernel.
RBF, okay, try.
That is called radial basis function.
Yes, 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 I know.
Okay, so what I did, I asked the classifier a function called SVM classify, where you have to give the structure which you have learned and the vector which you want to, you see in this particular, just a minute. This last slide of mine, where you have the test data set, you have given it to classifier. Once the classifier has been trained, and you ask it to give the output class, which it has given in the C vector, and you measure the accuracy of the classification. So what you will do, you will calculate the error rate by checking the sum where Y test this is not equal to. So you will one by one match Y test and C, and when that is not equal to. So I will just give you an example. Suppose this is your Y test vector, and this is your C vector, and these are the values. These values are 0, 0, 0, 1, 1, 1, 1, 1, 1, 0. So if it is not equal to this, you are checking. So here it is equal to, so it does not give any answer, 0. Here it is not equal to, it will give 1. Here it is equal to, it will give 0. So when it is not equal to, it will give 1. Here it is equal to, it will give 0. Here it is not equal to, it will give 1. So there are 2 places where it is not equal to. So there are 2 errors in 5. So your total errors will be 2 by 5 or 40% error. Okay, so like that you have written a function, sum of where y-test is not equal to this divided by the size of the total number of points. So if I run this code, it will run and do all these things, and the error rate is 0.06. That means 94% correctly classified, 6% incorrectly classified. And then you can also have a matrix called confusion matrix, where you y-test and c both are given. So it will match how many 1 are misclassified as 0 and how many 0 are misclassified as 1. The confusion matrix will be generated. So if you run this code, so this is 0, 0. So these are the correctly classified class 0 data, correctly classified class 1 data. This is misclassified, this is misclassified. So total misclassified are 2 plus 4, 6. Okay. So this is how SVM works. Similarly, you can have other classifier like KNN classifier is there. So the function for training is fit CKNN, fit classifier KNN, and the classifier used for test is called predict. Here you have to pass the training data set and the class level. Number of neighbors you have to decide, like I am doing 5. And once the structure is learned, I am calling it as KNN structure. You have to use it for testing, for finding the class of X test. So it will give me the class in C. Once it gives me the class in C, I will see whether the Y test is not matching with C, and then I will see the confusion matrix. So you can use any other kind of classifier, LDA or Bayes classifier. You just need to find those feature vectors, divide into training and test, and then apply the classifier.
So can you share the code?
Okay, I will share this code here or if you want, I will share the files as well. Okay, because here it will not be that much efficiently done. This is for KNN. This one was for KNN. And I will also share for SPM. I will also give those files if you want in a zipped file, like these 2 files, SVM my KNN code, my SVM code, that I will share with you. So now I will finish this particular lecture, and now you can ask me any doubt, and I know there will be a lot of doubts because I try to cover a lot of things in a very small lecture. But my aim was to give an introduction to machine learning.
Yes, sir. We have 10 minutes left. So shall we have the question answer part, sir?
Yes, yes.
Okay, sir. There is a question by Padmanatha Bhushumanam. Can you exemplify for 3D data of your choice?
I am not able to hear. What is the question?
Actually, the question was, sir, can you exemplify for 3D data of your choice? Means what we have done for 2D data.
Yes, the only difference will be if I go to the code, you see here, when you are talking about X-train in KNN or SVM, when you're talking about X-train, it does not say you whether what should be the dimension of the data, or Y-train, it does not. It just say that Y should be a 2-dimensional thing. That means there should be only 0 and 1 values, but X-train can be of any dimension. So just let me give you an example. Suppose you are having 3 features measured for 3 different things. So I call it as features X1, X2, and X3. Maybe in the cat and dog case, this is the length, this is the height, and maybe this is some information which you want, length of tail. Poonch ki height, the length of tail. So then how your data will be looking? Maybe these are the data set of cat, and maybe these are the data set of dog. But it will not be very easy to visualize this kind of thing. And when you will be having a classifier, it will not be a line. This time it will be a plane. It is sometimes will also called as a hyperplane. So if you can visualize in 3 dimension, suppose this is a room. This is your room, and here you are hanging your curtains, and then you tilt the curtains by some angle. So maybe something like this. Something like this. These are your curtains. So basically those curtains will be dividing the room into 2 different parts. One is on this side, one is on another side. So this is how a SVM will be working in a 3-dimensional case. How the KNN will be working, you will be having a new data point here, and it will be taking the equivalent distance. How the equivalent distance is taken? Suppose you are having a point here x1, y1, z1, and your point having here x2, y2, z2 in 3 dimension. So the distance, equivalent distance is calculated as x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So this is a 3-dimensional case, but you will not be able to use the function plot or scatter here. In MATLAB, you can go up to 3 dimension of plotting. I will just give you an example how you can do a 3-dimensional plotting. Suppose this is a function. So this is a 3-dimensional plot. I can use this particular cursor to move it and to visualize the thing. This is how the top view looks. This is how the front view looks. This is how different side views look. This is some function called Rashtrijan function. Let me use a very simple circle plot. So just a minute. No, okay, circle, plot circle. This is a circular plot. It's like a bowl. So this is how the top view. This is how the top view look. The blue color is, this is the depth, this is the height, and then maybe this is like the side views. Different side views look. It has got the. This is a function of x square plus y square. So it is 0 at 0, 0. At 1 it is 1. Height is 1. At 2 the height is 2. 8 x square, that is 2 square is 4. Plus y square, 2 square is 4, 4 plus 4 is 8. So at 2, 2, the value is 8. So this is the different views of 3D plot. Okay, but for more than 3 dimension, you cannot use. Instead of scatter, you have to use the function called surf. So you have 3 values, x, y, and z. You have using the function called x, y, z surf. So it will be plotting a 3-dimensional function. But not more than 3 dimensions can be done. But practically, when you will be using any classifier, it will be of more than 2 dimensions. Very rare will be there when you will be using a 2-dimensional feature. Any other doubt?
Yes, sir. There is a question by Dr. Suresh Peria.
Yes, what is the question?
Sir, would you repeat how to test the accuracy, or that previously you had said in the previous slide?
Okay, so what I have done, I have asked the classifier, like I have asked the classifier here, to predict the class, and I am saving it into C. Okay, and I also know the original class, which is y-test, because this is a supervised learning. In supervised learning, with each test data point or training data point, you also have the class level known to you. So y-test I already know, but the classifier give me the class level C. So if I test C here, this is my y-test function. This is my y-test. It is not. This is y-test, like 1 1 0 1 0 0 like that, and this is C. 1 1 0 1 0 0 like this. So one by one, I will be matching them. So first value of y-test versus first value of C. It is matching, so it gives me the non-matching things give me 0. So just let me just give you an example here. Suppose this is my C vector. This is 1 cross 2 1 1 0 0 1. Okay, so this is C. Now let me have y. Randomly I am having 1 1 1 0. Dimension tha 1, 2, 3, 4, 5, 6. Okay, so this dimension is also 6. C. Now I will have same code which I was showing to you. I have to sum y test not equal to c, or I have to write, say, a is equal to okay, some dimension mismatch problem. What is the dimension of x? 1, 2, 3, 4, 5, 6. And what is the dimension? Just a minute.
So actually, there will be a variable problem.
No, that was not a problem. There was the problem like earlier we also had the same test, same variable. So this is my y, this is my c. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Now I use a function called, okay, I have to write this code. Y not equal to c, not y test not equal to c. So this is the value. That was the last place where the c and y were not matching. You see, if I write a is equal to c, comma y, this is the only place where it was not matching. This was matching, this was matching, this was matching, this was matching, this was matching. The last place it was not matching. That's why in the answer I got 1 here. So wherever there is a mismatch, this function will return me 1 there. I will sum all of those ones. So that is the total number of errors. I will divide it by the size of y. So if I have, just let me show you. What do you mean by size of a function? So suppose I have this a vector. If I write size of a, it will give me 6 rows and 2 columns. But if I want only rows, I will write size of a comma 1. So it will give me there are 6 rows. That means first dimension is 6, second dimension is 2. If I write size of a comma 2, it will give me 2. That is, there are 2 columns. So the line which says size of y test comma 1. So how many rows y have? It has 100 rows. So total number of error divided by total number of points. So the summation is called the error rate. Any doubt now, sir?
0.6. 0.6.
0.06. That means 66% error.
Yeah.
How to make error analysis using regression line find for better decision making. So this regression, because the time was limited, I have not covered in this. Regression is something different from classification.
Okay.
Okay. Any other question here?
I think we have covered the whole time, sir.
Okay, sir. Thank you, sir.
Okay then.
Okay, sir. Thank you, Dr. Rahul Chaurasia, sir, for such a wonderful session. You have done. Actually, the second part is also good. Second part was really good for a hands-on practice. Hope participants have done their practice simultaneously. Those who have not done, don't worry. We have the code here in chat box. They can copy. Otherwise, we can provide, sir, codes.
Yes, I will send you those 5. So I have got different 5 files. 2 were for this SVM code and KNN code. This was not a big code. This was some kind of assignment which I used to do in my institute. And this is this task 1. So these all I will share to you in WhatsApp. Okay, then you can share it with your participants.
Sure, sir. Thanks. Thank you, Suresh, sir. Thank you, Padmalata madam, for your nice feedback. Actually, the session was really good. So, thank you so much, sir. Hope we will have some knowledge, some guidance in future. Have a nice day. Thanks for the participants for joining for such interaction. Thanks for being. Have a nice day. Good night.
Okay, sir. Should we leave?
Okay, sir.
Okay.
Thank you, sir.
Sure, sir.